Have you ever wondered why we say light travels at a speed of 299,792 kilometers per second? It's a common phrase we hear, but it also leads to a common misconception. Many of us think of light as moving or traveling just like a car or a bullet from point A to point B. However, light isn't just a simple object. It's a complex phenomenon that exhibits a dual nature. It's both a particle and a wave. This dual nature often leads to confusion and misunderstanding. We tend to oversimplify, trying to fit light into boxes it doesn't belong in. So, what if we've misunderstood the way light behaves in our universe? What if our perception of light's speed is just a product of our limited understanding? Let's delve deeper. Light, as it turns out, is a sneaky character. It behaves as both a particle and a wave. This is a concept known as the particle-wave duality of light. Let's start with the wave-like properties. When you drop a pebble into a pond, ripples move across the water. This is similar to how light behaves. Experiments show that light, much like ripples in a pond, can interfere with itself and diffract around obstacles. Interference occurs when two or more waves overlap, creating a new wave pattern. This is most noticeable with light in the form of colorful patterns, a phenomenon demonstrated in the famous double-slit experiment. Diffraction, on the other hand, is the bending of light around corners or through openings. When light encounters a barrier with an opening, it doesn't just pass straight through, it bends and spreads out, creating a wave pattern on the other side. Now let's turn to the particle-like properties. Light also behaves like a stream of tiny particles, or quanta, called photons. The most striking evidence of this is the photoelectric effect, an experiment that won Albert Einstein his Nobel Prize. When light shines on certain metals, it can knock electrons loose. But this only happens if the light is of a high enough frequency, regardless of its intensity. This is as if the light particles were little billiard balls, striking the electrons with enough energy to dislodge them. This dual nature of light is one of the cornerstones of quantum mechanics, a branch of physics that describes the bizarre and counterintuitive behaviors of particles at the atomic and subatomic level. In conclusion, light is a chameleon of the physical world. It refuses to be pinned down as either a particle or a wave. It's both. And yet these aren't two separate aspects of light, but two faces of the same phenomenon. So light does not travel in the way we typically understand, it propagates. But what does that mean? Let's explore this further in the next scene. When we say light propagates, what we mean is that it spreads out from a source. Think of a light bulb in a dark room. The moment you switch it on, the room is illuminated almost instantly. This is because light, once produced, propagates in all directions, reaching every corner of the room. But how does it do this? Well, it's not quite like how we usually think of movement. Let's take a closer look. Imagine you're observing a star, a distant one, billions of light years away. The light from that star is reaching your eyes right now. But here's the catch. The star itself hasn't traversed those billions of light years to get to us. So what's happening here? Well, when light is created, it sets off a kind of chain reaction. The energy from the light source jostles nearby particles, and those particles in turn jostle their neighbors. This process continues, creating a wave of energy that ripples outwards. This ripple, this wave, is what we perceive as light. This propagation happens at a very specific speed. You've probably heard of it, the speed of light. And it's incredibly fast, allowing light to reach far-off corners of the universe over immense stretches of time. So if we go back to our star, the light you're seeing isn't from the star physically traveling to you. It's from the energy that was released when the light was first created, propagating through space and finally reaching your eyes. In essence, light is a kind of energy messenger. It carries information from the source to the observer, without the source itself having to move. It's a fascinating process, and it's happening all around us all the time. So, light doesn't travel in the conventional sense. It propagates, spreading out from a source in a wave-like manner. It's one of the many reasons why light and the physics behind it is so incredibly intriguing. So why do we say light has a speed? Well, when we talk about the speed of light, we're not referring to a physical object zipping through space. Instead, we're discussing the rate at which a wave-like disturbance caused by light travels. Imagine tossing a pebble into a still pond. The ripple created by the pebble's splash is akin to the propagation of light. The ripple, or wave, moves outwards at a certain speed, spreading the disturbance across the pond. This is precisely how light behaves. The speed of light is a constant. It doesn't matter if you're stationary or moving relative to the source of the light. The light's wave propagation will always travel at the same speed. It's a universal constant, universally misunderstood. So when we talk about the speed of light, we're really talking about the speed of the wave propagation, not the speed of a physical object moving through space. So, we've debunked a common misconception in physics today. We've journeyed through the fascinating world of light, its dual nature as both particle and wave, which seems to defy our everyday understanding. We've explored how light propagates, reminding ourselves that it doesn't travel from point A to B in the conventional sense. It's about the oscillation and propagation of electric and magnetic fields, an interplay that gives birth to the phenomenon we know as light. And then, we've clarified the real essence of the speed of light. It's not about how fast light can race, but rather, it's an inherent property of the universe, a cosmic speed limit, if you will. It tells us about the fundamental structure of space and time, so next time you hear about the speed of light, remember it's not about a race, it's about propagation. Thank you for watching and keep questioning.
Please do like, share and subscribe to my channel.